Hello everyone, I am Bob and this is the Home Bitcoin Immersion Mining channel. In this design series episode, we're going to cover the mining cooling loop, including sizing pumps, sizing heat exchangers, and laying out the components of the cooling loop. So with that, let's get started. Okay, so in previous episodes, we covered everything from sizing a system up to installing a Bitcoin immersion mining tank. Now the next step is to design the cooling loop for the miner side of a dual loop system. Now this loop consists of the mining tank, which was covered in a previous episode, a pump to circulate the cooling fluid within this loop, a fluid filter to protect the pump from damage, and a heat exchanger to transfer heat from this loop to the second cooling loop, which will carry the fluid to the outside of the house for cooling or for other locations in the home for use in heating. So stepping through these components one by one, the first to look at is the pump. Now, there are lots of different types of pumps out there. They're all built for different uses, different flow rates, different pressures, different designs, different fluids. But the type of pump that is perfect for circulating fluid in a Bitcoin home immersion mining system is what is called, obviously enough, a circulator pump. Now, these pumps are mostly designed for and used in residential systems such as hot water circulation and hydronic applications. For that reason, they're relatively quiet. They are built to be very reliable, able to run nonstop over years, and there are many different sizes and manufacturers to choose from. And so this makes circulator pumps perfect for use in a home Bitcoin immersion mining system. So from all of the available pumps out there, how do you pick out the right circulator pump? Well, the key to choosing your pump is to understand pump curve charts. These are produced by pump manufacturers for each pump they produce, and these charts describe how a circulator pump will perform in your system. Now, there's a great video out there by another channel explaining these pump curve charts, and I put the link below. I highly recommend taking the time to watch it, but I'll also quickly try to walk through how to use these pump curve charts and size a pump here. So this is an example of a pump curve chart. On the horizontal axis is the flow rate, usually noted in gallons per minute, and this is where we set the target flow rate for a system. If we remember from the tank design episode, the target flow rate is going to be between 1.5 and 8 gallons per minute, depending on the number of miners you use, what type of miners, are you going to use overclocking. And so with that number, the first step is to find your desired flow rate on the horizontal axis of the chart. With that set, the next step is to figure out your needed fluid head on the vertical axis, and this is where things get tricky. The way to understand this fluid head is if we attached a wide tube to the outlet of the pump. This is how high the fluid could be pumped at a given flow rate. Now, the reality is that we're not going to attach a wide tube to the top of our pump. Our pump's going to be attached to the rest of our mining system, which includes all sorts of piping and elbows and other things that restrict the flow. So how exactly do we use this chart? Well, first we want to start by measuring the vertical distance from your pump to the highest point in your system. This gives you a starting estimate for that fluid head that you will need. Now here's a diagram of an example system, and in this case the pump is the lowest point in the system and the highest point is the top of the tank. So the height between these 2 points is going to be your starting estimate for the needed fluid head. Now, in addition to that height distance, we will also need to add the effects of the components in the system between the pump and the highest point in the system. And this is where things get really tricky. You have to estimate how much pressure drop is caused by each component, then convert that to an equivalent head distance, and then add that to your estimate. And this gets even more complicated because the faster the fluid moves through this system, the more resistance there is to your fluid. So this gets to be somewhat of a computational mess. And really at best, this becomes somewhat of an educated guess. So the way you want to do this is start with the height difference between your pump and the highest part of the system, and then maybe add 5 to 10 feet to that number. Guessing high is probably a good idea because you can always throttle back your pump with a valve attached to the output. So with those two numbers in hand, the flow rate and the estimated head height, now things get pretty straightforward. You find a pump manufacturer and a pump model, get a hold of the pump curve chart. All manufacturers will have a chart on their website for all of their pumps. And then you just find the intersection of your flow rate and estimated or guessed head height on the chart. Now, if your pump curve is higher than this point, the pump will flow a little more than you need. Now, as long as it's only a few gallons per minute higher, the pump should work. Alternatively, if we find the intersection of the flow rate and head height on the chart and the pump curve is lower than this point, then the pump will definitely flow lower than you need. And in this case, you should definitely search for a different pump. So let's go through a realistic example to show you how all of this works together. Here is a pump curve chart from a pump manufacturer. And now let's say, for example, I've got two S19s that I'm deciding to overclock with the resulting power input of 8,500 watts. Now from episode 4, where we covered how to calculate needed flow rates, this means I'll need about 9 gallons per minute of fluid flow. Now let's say the distance from my pump to the top of the tank is 3 feet, and we'll add about 8 feet worth of fluid restrictions as a rough guess, and that gives us a head height of 11 feet. Now finding the intersection point on this chart for a pump running in the US with 60 hertz power, we can see that the curve is a little higher than we need. Now this looks great, but to make sure, let's do a quick check to see how much extra flow we're going to get. Extending rightwards to the curve and drawing back down to the horizontal axis, this chart shows that we'll get about 10 gallons per minute with this pump and this estimate of fluid restrictions. So in this case, the pump should work. Okay, so now that we know how to use these pump curve charts, where do we get these circulator pumps? Well, there are a lot of manufacturers out there. Some of the major manufacturers are Bell and Gossett, Grundfos, March, Armstrong, Taco. There's others out there, and they all will have multiple models of circulator pumps in and around the size that we need. Now, I've got some links below for some models that should be around the right size for a home Bitcoin immersion mining system. Now, one last point to be aware of here is that all these pumps are designed for cooling loops using water or water glycol mixtures. None of these pumps are designed with Bitcoin or miner dielectric fluid in mind. So before you pick out your pump, get a hold of the manufacturer's data to understand what are the internal components of the pump and what it's made of. If you can, find a pump with most, if not all of its internal components on your fluids material compatibility list. Now, in looking at these pumps, you'll find that they're not that cheap. They can run up to $400 or more per pump. However, they will run for a long time if treated well, and the key to a long life is to avoid any solids or particulates from entering the pump and causing damage within the internal impeller assembly. And the best option to avoid damage is to put a filter in the system before the pump. Now, there are a lot of different types of fluid filters out there for different purposes, different fluids, different flow rates. However, the best type of filter to remove solids or particulates is called a Y-strainer filter. Now, this is a very common type of filter, and there are lots of different models and manufacturers out there. Their cost ranges from about $10 to $50, and so this is very cheap insurance to protect your expensive pump over the long term. I put a few links below for some models that should work for home Bitcoin immersion mining system sizes. Hey folks, just a quick reminder to hit that like button so the YouTube algorithm will share all this good content with other people, and for you to hit the subscribe button so you won't miss any good content coming your way. With that, back to the episode. Okay, so the next component to look at is the heat exchanger. And the purpose of the heat exchanger is to transfer the heat from the fluid in the minor cooling loop to the fluid in the secondary cooling loop. There are a few different types of heat exchangers for transferring heat from one fluid to another, but the type that is used in most dual-loop Bitcoin miner setups is called a brazed plate heat exchanger. They're very compact in size, they're very efficient at transferring heat between fluids, and there are a lot of sizes and manufacturers out there. As for how these work, there's some great videos out there explaining how a brazed plate heat exchanger is built and how it works. They're generally put out by the manufacturers. I put a link below as an example. You can search for other examples of this on YouTube if you want to know more. Now, with a brazed plate heat exchanger, the most important question you have to ask is, what size do you use? And this is actually a really tough question to answer. You have to know the fluid flow rates in both coolant loops, the temperature changes in one of the loops, thermal properties of both fluids, heat transfer properties of the heat exchanger itself. It actually is a pretty complicated problem to solve. Now, in general, the folks who understand this the best are the heat exchanger manufacturers themselves. Some of these companies will offer calculators online or let you download some software offline to figure this out. But for most manufacturers, you will have to call them up and give them the data to run through their proprietary tools to figure out what type and size of heat exchanger that will work best for your setup. Now, I've played with some of these design calculators and done a few back of the envelope calculations myself, making some assumptions along the way, and in general, some guidelines to work from. For a two miner setup, if you're looking at a 4-inch by 12-inch heat exchanger, you'll be looking at maybe a 30 plate design. And for a one miner setup, again, a 4-inch by 12-inch heat exchanger, you'll be looking for something like a 20 plate design. Now, the last topic to cover is the arrangement of these components around the miner fluid loop. Now, the big question is in what order do we put these components? And the key to getting this right is to understand how these circulator pumps work. Circulator pumps are designed to generate fluid flow and fluid pressure. They are not designed to generate suction. In fact, most circulators are fairly limited in their ability to pull fluid into the pump. For this reason, the loop needs to be designed to feed fluid into the pump via gravity and designed for the pump to drive the fluid through the rest of the system. So when designing the mining cooling loop, it is a good idea to put the pump at the lowest part of the system. It's also a good idea to have the major fluid flow restrictions, such as the heat exchanger, on the outlet side of the pump. One exception, of course, is the fluid filter. We want to make sure that that is placed before the pump. This arrangement also helps with avoiding air pockets in the system. Air pockets can cause problems in that these can create air bubbles in the fluid that can flow up into your mining cooling volume. These air bubbles can settle on electronics, forming hot spots that could cause small components of your miner to overheat. So having the pump at the lowest point with all the components and piping above the pump will help work all the air out of the lines as the fluid flows through your system. Now, the last components to add to the cooling loop are sensors and valves. Now, sensors will be discussed in future episodes where I'll cover what type of sensors to add, why to add them, how to use them, and so we're going to skip those for right now. For valves, installing valves separating the tank from the rest of the system is a really good idea. This will enable you to keep the tank filled in the event that you need to work on your pump or heat exchanger. You can just isolate the tank and drain the rest of the system. In this case, ball valves are probably the best to use since when they are fully open, they have minimal restrictions to flow. Another valve to consider is a valve near or at the lowest point of your system. This valve will enable you to completely drain the tank and all the components of the system if needed. For this type of valve, a gate valve is recommended since we don't really care about fluid restrictions here, and gate valves are designed to form a very tight seal when they're closed. And the last part of the mining cooling loop designed to cover is the piping material itself. Now, there are a few different options that will work. You have metal piping, plastic piping, and flexible tubing. Now, for metal piping, pretty much any conventional piping material will work. However, for plastic piping, not all materials are compatible with these dielectric fluids. The normal white PVC piping cannot be used. It will degrade over time when exposed to Bitcoin mining dielectric coolant, and eventually it will kind of fall apart. Instead, your option is to use CPVC piping. Now, there are two different types of CPVC piping out there. There's Schedule 40 pipe, which is off-white or yellowish in color, and this is available in 3/4 inch or 1/2 inch piping sizes, and this is available in most home improvement stores. The other type of CPVC piping is Schedule 80 pipe, which is gray in color. Now, it is much thicker and heavier built than Schedule 40 pipe, and it is available in sizes all the way up to 8 inches in diameter. It is much more expensive than Schedule 40 pipe, and you're going to have to go to an industrial supply shop to buy it. And the final type of piping is flexible tubing and hosing. For this option, you're going to have to find a hose material that is compatible with your dielectric fluid. Now, there are a lot of different types of flexible tubing materials out there, so finding a compatible material might be a little bit of a challenge. Now, when it comes to hooking up your piping to the rest of the components in your system, regardless of the type of piping you use, preventing leaks is going to be a bit of a challenge. The dielectric fluid tends to be more difficult to seal than what you might be used to when working with other fluids such as water. For this reason, it is a good idea to avoid using threaded connections when possible. Instead, try to use welding techniques such as soldering or solvent welding to connect your different system components together. Now, you don't always have a choice. Pumps, heat exchangers, other things may be built with threaded connections, and you can't avoid that. So, in those cases, you'll want to make sure you use a good pipe thread sealant, such as tape with pipe dope, to make sure you ensure a good seal and avoid leaks in your system. And so that's all I have for this episode. We covered some really good stuff. We covered sizing a pump, we covered sizing a heat exchanger, and we covered laying out the miner cooling loop. Now, in next episode, I'm going to show you how I use that information and how I've built my own miner cooling loop. So with that, bye.